back, this time some live development. Got a question from Red about this section, Celsius, blah, 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 within Elements.Quantity. So let's take a look. By the way, I don't know why Visual Studio is rendering this image in this manner with two separate copies of it, but whatever. We'll move on to actual code. So let's head on to temperature, and I'll go to the location that he is referring to, which is here, Celsius. All right, so they're asking about this bit here. So what we need to do there is to look into the unit nonlinear constructor. And you'll see here that there is a function which says convert to and convert from. So what this is doing is it's saying, hey, when you construct me, add two functions, one that converts to this unit and one that converts from this unit. And func here means takes a double, returns a double. So now we can head back to temperature and we can see that, yes, these are two lambdas. And what they say is take the incoming value, which would be in Kelvin, and we can see that it's in Kelvin because the base unit of this quantity, which we can find, it's somewhere. Here we are. Default unit returns Kelvin. So here we are. The Kelvin to Celsius adjustment is minus 273.15. That'll basically, so at Celsius, at 0 degrees Celsius, you're 273 degrees Kelvin, because there are 273 additional degrees of Kelvinness before you get to a temperature referred to as absolute zero, which is where the molecules inside whatever you're freezing are so cold that they don't move. When you think about temperatures like that as well, it's important not to think about things like ice and snow. It's more like an X-Men power, right? The molecules are just stopped. The only reason why ice and snow are associated with cold things is because water's everywhere, and when water get cold, it turns into ice. That doesn't happen like in a lab. You put like a chunk of metal into a freezer and cool it down to zero. It's not going to be any water around. I don't know why I went on that tangent, but there we go. So yeah, this is just two conversions. He also did ask how to use those. And so what we can do here is we can say, hey, are there any references to this particular thing? And you can see, yes, we have some in the tests. This is temperature test data tuples. That's difficult to pronounce. So we'll have to take a look at how this is used. If it's constructed into the format tests, which it looks like it is, yes, it is, then they are not the kind of test that we need to do. We're actually going to go ahead and write the tests in this video. So if we go ahead and we take a look at angle, I wrote some tests for angle recently. They'll be over here in angle tests. So these are the naming tests, and then beneath that, you'll see here that we, that's still formatting here. These tests are more structural. They do with the conversion functions rather than the string functions. The string functions internally will use the conversion functions, but it's important to test both separately because the formatting tests give you a bunch of strings, whereas the numeric, like structural tests here, they give you a bunch of numbers. So it's really easy to sort of see if there's a problem when the numeric tests fail. So we're actually going to do that. We're going to drop this one down to here because it's somewhat useful as a structure. So instead of radian to degrees, we can rename this to Kelvin to Celsius. And so this is going to be K. We'll use the same convention as the incoming item. So KC. Actually, we need to rename this to expected C. And because this is a test, I'm just going to go ahead and type these out. I don't like it when we know we can. So what we need to do here is we have a Kelvin value, so we can do temperature equals new. How was I doing that with a? Yes, I was doing it with new. So it will be var temperature equals new temperature, and we should pass in the Kelvin. And so now we have a temperature unit that is Kelvin. We can now convert that to Celsius by doing expected Celsius, and then it will be temperature dot convert to temperature dot Celsius. Now I'm going to comment this one out because it's not valid. And then I'm also going to fill in a couple of known things in here. So like I said, 0 should convert to 273. 273 Kelvin should be double that. So it should be like 273 times 2, I think. We should also check that this be negative 273. Yes, and then 273 should be positive. We'll do that. Half the reason for running these tests is because I don't know how this stuff works, so we can actually now figure that out. Where are we? Oh, we're in here. Okay, cool. So here's the temperature tests, Kelvin to Celsius run. This will rebuild the project and just run that test for us. And it fails. It fails both. Oh yeah, 15. Yep. So I can make this a bit bigger. What this is saying is expected difference of no greater than 0.1 between expected value negative 273 and actual value negative 273.5. We're going to go ahead and constrain that to 0.5, but also leave in this 0.1 just in case floating point sticklers us. 273.15. Yep. And then this one failed. Okay, I apparently don't know anything. 273 Kelvin. This is floating point as well. This is actually really good to kind of like check. Should be like around about 0. Oh no, because this here, 0.15. This should be 0, but we want to keep that in because as you can see, we're being floating pointed. There we go. I could have just like alternated these, but whatever. I want to test the boundary as well. This one I think should be 273.15. Because I want to test the positive boundary as well. Yeah, positive boundary works as well. Any other boundaries we should test? No, I think we're good there. You can PR in more if you come up with any. So there's Kelvin to Celsius. So now what we're going to do is take this and copy it. And we don't need this. It's just going to be easier to refactor this. This will be Kelvin to Fahrenheit. And then we can do Kelvin and then expected Fahrenheit. And then this changes to Fahrenheit. This stuff is like a lot to do, but like trust me, the next person through the code loves you for it, because otherwise like that would be like, I don't know, EX. You know, someone might say like EX, that means expected. I'm like, no, it's expected Fahrenheit. As they say in science, always write your units. We do temperature.Fahrenheit there, and then we can see how wrong this is going to be. Now, I don't know these values, but like I'm pretty sure the code's right. So we can run these. They'll fail, and it will give us the like correct values. And I'll check a couple of these off camera. Trust me. Negative 450 Fahrenheit's weird, man. Fahrenheit. If this is like any proof that Fahrenheit is weird, between 0 and the expected and the actual value, 31.9. That's 2, isn't it? 0 degrees Kelvin is 32 Fahrenheit. Let me look these off camera. Okay. Kelvin to Fahrenheit converter online, and we'll code it from this. So 1 Kelvin. Oh, that's right. We should do 1. 1's another good one to do. So we'll do that here, and then I'll just handle that differently here. So it'll be 1 Kelvin. And this is DuckDuckGo telling me that it's minus 457.87. And we'll move that one to the top. Okay. 0 degrees Kelvin is actually, yeah, that number. That's correct. 273.15 Kelvin is 32 Fahrenheit. Yeah, that makes sense. The boiling point of water is 0 in Celsius. So see up here it says 0. And so boiling point, freezing point of water, sorry, is 0 in Celsius, and it's 32 in Fahrenheit. And then this is 546. Should be 523 Fahrenheit. And then we'll just do 1 Kelvin into Celsius. It's important to do the 1 case. That is that number there. So we can grab this. And we can do that. Now these should all pass. So we'll just run the entire temperature test thing. That one didn't run because it was new. There we go. Oh, 1 didn't work. Expected value. All right, so we check this one using the website again. Simply because I've forgotten. 546. Oh, it's the times by 2 one, yeah. 546.3. No, wait. 546.3. Which 1 Kelvin to Fahrenheit. Oh, I've still got Celsius selected. Okay, 500. you gotta hate me. Okay, I'm sorry. I'm sorry. Damn it, the Unicode doesn't work. Ah, yes. No, that's too small. Okay, we'll do Unicode. I'll leave it like that. All right, so that is Kelvin to Fahrenheit. So let's go back to the question. Speaking for 14 minutes, mostly drivel, whatever. My channel, my rules. Is that the conversion to other temps? We got that. Yep. I edit this, I think it would work. Ah. Ah, do you mean like another... What is ah? I should have asked this. What is ah? I'm asking them live. Let's take a look at what Fahrenheit currently says, and then we can see... So it doesn't have ah. Oh, Renkin. Renkin. Do we have Renkin? Renkin. Ah, they're probably adding Renkin in a PR. I should have asked this anyway. This is great because what it shows you is how I'm doing it. Why does it? You are right though. So the second part of that question was like, the first part was how do I use these? The second part is really like why are there multiple here? So you can see there's K, that's 1, and then there's F, that's 2. Well, that's obvious. That's because it's from and to. Yeah. I don't know why I was confused about that. I think I was reading their example. Yeah, so for Fahrenheit, for Renkin, you'd need another line here that is like Renkin, however it's spelled, Renkin. And then you would need to do the ratios here, figure those out, and these as well. However, based on your next message, which said something like it was only converting between Kelvin and Fahrenheit, I think we can cross convert. So let's figure that one out. I'm going to go ahead and like just abuse this test for a second. So we have a temperature value in Kelvin. I want to make a temperature value in Celsius. So Celsius equals new temperature. Temperature dot Celsius. I swear I knew how to do this. Temperature. Oh, here it is. You do temperature. No, it can't be pass. Base. It's something to do with base. I was literally doing this the other day. Here we are. No, because that just used. Ah, here we are. Temperature dot Celsius dot convert from, and then you put it in a double value there. So we would put in Celsius here, and it would give us a temperature value. All right, so let's make the new test for that as well then. So we want to see that cross converting works. So we'll do Celsius to Fahrenheit double Celsius double expected Fahrenheit. Yeah, it's picking it up. It's got a far temperature. Temperature equals new temperature Celsius. Yes. And then we can say equals temperature dot Celsius. No. Temperature dot Celsius dot convert from, and then we put in Celsius, and then we delete the previous line because we didn't actually need that. Temperature, and so that's like, hey, we have a temperature from Celsius, it's into the temperature system, and then we want to output it as Fahrenheit. So then we do assert r equal, and this will be the expected Fahrenheit, comma, temperature dot convert to temperature dot Fahrenheit 0.1. This will work, but like I don't like it. I'll talk about that in a moment. So it's Celsius 0 to Fahrenheit 32. That should be an easy one to handle first. Yep, Celsius to Fahrenheit worked. Now, the reason I don't like this is because there are two steps. There are two steps. We have to create it and then convert it into. I think there might be another way to do this, so just give me a moment. Temperature.Fahrenheit.convert from, yes, temperature.Celsius dot convert from Celsius. There you go. So we can now actually just say like, hey, the result is this. What is the problem? Brackets. No? Double to float. Convert from... Oh, yeah, we need to do result dot base value. Thought we would have an implicit. Does it really not have an implicit? No, it does not. I want to look into this more, probably outside this video, because if there's any location that actually has something in here, it might show that in a little bit of a better format. But that tests that method like sufficiently, and the reason why is because what happens here is we actually go through Kelvin. So if you go into convert from, you'll see that it does default t.new, which we need to go to implementation for. Temperature. And it does return new temperature base value. Yes, and what does it pass into? Val minus tightness ratio. Yes. You'll see ratio is in this unit. So when we make a unit, we give it a ratio. So we can go to here, where we can see that Celsius as our input has a, where are we? So unit nonlinear. Ah, yes, because it's a unit nonlinear, it won't actually use what I just showed you. Instead, it'll use all this stuff. You see, convert from. So what it's doing here in the convert from is it is taking the Celsius value, and it is converting it into using the convert from, which we remember is the Celsius to Kelvin. So convert from Celsius to Kelvin. So it's in Kelvin. And then this takes that temperature and converts it to Fahrenheit. So there we go. I'm actually interested in, like, you know, it's my channel, so I don't really care. I'm going to go ahead and take a look and see if I can find an existing conversion that we might be able to take a look at. So this will give us everywhere that's got region conversions in it, and we can just go through them. Ah, this is cool. So here we can see that you should be able to, in code, do something along the lines of like, let's say you have an acceleration a, and you have a time t, you should be able to say a, oops, it'll be like a times t. We're not in a like method body here, so it's going to complain. That would be an interesting activity for someone to write some tests for, maybe. That doesn't really help us. I need to see more. Skinner. Oh, well, these are really cool. These are in voltage. So again, if you have resistance and you have current, you can multiply. Is that correct? V equals IR, right? Or is it IR? IR. Voltage formula. Oh, it is I times R. Yeah, okay. I multiplied by R. So, if you have a resistance and a current, or a current and a resistance, you can multiply these two together, like this, or like this. It won't matter, and it will output a voltage. That's cool. So it's common conversions between units. Okay, sounds cool. Let's see if there's any more. We were just looking at that one. Okay, there are no more. So let's see if we can write one. No, I don't think we can, because it's like... Let me give it a go. I don't think I'd probably check these in, because they... I don't know what I'm doing, so we'll see what happens with... I don't know what I'm doing. Public static temperature dot Fahrenheit to Fahrenheit. Oh no, it can't be static. It has to be. We have to use an instance. Yes. It's not the data type is unit temperature. To Fahrenheit. Return. Convert. This dot. Convert to temperature dot Fahrenheit. And let's go to unity to there we go. And then we can do chuck Celsius in there. Now, I do have a problem with these, though. The problem is that... Oh, I'll show you the problem. If we go back to here, we could then rewrite this test, and it would be var result equals temperature.Celsius, because we still have to do it this way to get the Celsius out. And then the result would then be dot to Fahrenheit. So we haven't like improved that that much, but we have made the result afloat again. All right, so that still works, but the problem is that this is now it's not chainable. If this returned a temp, I thought this was returning a temperature. If it returns a temperature, we got a problem. All right, so now we got to see if we can improve this side. So how do we make a Celsius temperature really easily? There is parse. The reason I'm not using parse is because parse is for strings. What's this do? Ah, you have to put a quantity in there. Yeah, convert from looks like the way you're meant to do it. That's parsing. We don't need to figure that one out. Public static operator multiply. Multiply by the... Ooh. Okay. If I'm reading this correctly, you should be able to do temperature dot Celsius multiplied by Celsius. Uh, okay, let me read that again. I've lost it now. I think we went into unit. And then it was some sort of multiply. Here it is. Static T. So the unit T multiplied by double N. If we do it the other way around, Celsius multiplied by what? Okay, well screw this. This is much easier. Can we do it the like other way around again? Hell yeah, we can. What is this result though? Oh, it's a temperature, so it needs to be result dot O. Because the does the does the oh yeah, the order of operation does that, right? So it's going to return. No, it does the same operation, which means we get a temperature out. Okay, so now we need to look at a temperature and see what operator it has. Celsius multiplied by temperature till Celsius. And that gives us a, yeah, that still gives us a temperature. So this would then have to be like, I think. Yeah, that passed. Well, I don't think that's like any better than what we had before. Well, it kind of is, but you know. There's no like temperature multiplied by a unit that we could do maybe? Because like what we could then do there is like, hey, this makes it a unit that you've got in Celsius, and then this turns it back to Fahrenheit. That sounds a bit silly, but like we could also do that. Let's take a look at doing that. So this would be, I'm gonna need an operator to like play with. So this would be, it would return a double. It would take, a temperature and a unit temperature, U, and then it would do return it would be a dot convert to U. I think that would work. It's basically doing this, but by like another name. Why can't we just arrow function that? Let's just arrow function that. Much better. So then we can go back to our temperature test, and this should now be a double, and we could go ahead and do this as well. Hooray! However, I don't know which one's best then. Like maybe I'll just like publish the video and we can like see which is best, because all of these will now work. We can do expected Fahrenheit here, bracket this one. This is our like magical thing that doesn't really make much sense. We could also do this one. Give me a second here. Convert. Bring this out again. Make sure we get what we expected. I don't know what I was doing there. I think it was temperature dot Celsius dot convert from Celsius dot to Fahrenheit. There we go. There's another way of doing it. We can get rid of this one, and we should put the 0.1s back in. But then this was the other one that I was doing, which was convert to temperature dot Fahrenheit. So now I've got 3 different ways to do it, and I honestly don't know which one is like better. But there you go. All the temperature tests pass. I will put a PR in for Kelvin to Celsius, Kelvin to Fahrenheit. I will not PR this one because I'm just like, I'm not sure what's going on here. Maybe you guys can comment and let me know which one you like. This scares the crap out of me. Also, I think that think there should be an implicit that converts it to a double as well, so I'll look into that one. I don't really know how to write those though, so maybe there's one in here. No, there are no implicits. Is that for another video? Screw it, we'll do it now. Implicit operator. All right, cool. So for the implicit operators, we would head over to temperature, and we would do yes, here they are, operators. So we would do public static double double temperature t dot base value. Oh, I didn't put implicit in it. It is static implicit operator. It's like that. Problem with this though, like, is I couldn't do like that. That wouldn't work. But that allows us to do allows us to do things like, where are we? Wherever base value is used, we can go to like the angle tests. Yeah, here, angle and base value. We can just be like, boop, nope, double now, please. Cannot convert from double to float. You are a double. Double. Cannot convert from angle to. Oh, it's because I didn't add the implicit. Right, I need to add the implicit operator to angle if I want that to work. It's only on temperature. So for temperature, we could do. We don't use base value anywhere. I'm not sure if that was case sensitive. Who cares? We'll just do it anyway. So we can do test method public void test implicit operator. Just do var t equals new temperature 273. And then we could do assert r equal. Let's do this properly. Come on, do this properly. Const Kelvin equals const double. Kelvin T. So there we go. It takes us through the implicit operator, and it means that because here we are, it should also be just because it's a float or a double. So Kelvin is a double. T is a temperature, but because it has that implicit operator that I just added here, in context where it needs to be represented as a double, it will automatically convert itself to a double. Again, I won't PR that yet because I need to have a look through the rest of the library and see how that works. But we can go ahead and get that test done as well. Where are we? Temperature, test implicit operator run. Boom, it passes. I'm going to check one more thing. I don't like any of those. nu is. It looks like a non-constructor version of nu. Unless that is the constructor. It's a struct, though. I'm going to stop talking before I say something stupid. No, here's the constructor. So why does this exist? To use that, you'd need to do you need to do like t.new and then put like a base value in. I don't know why you'd avoid. Okay. Anyway, I hope you learned something, and I'll speak to you soon. Once again, is that how it's meant to be done? Celsius multiplied by Celsius multiplied by Fahrenheit. Shrug.